In this tutorial, we demonstrate how to construct a spreadsheet simulation model using only native Excel functionality. We will use the Landshark example to demonstrate. In the Landshark example, Landshark Incorporated is a real estate company which is proposing to bid $1,230,000 in an auction for a property estimated to be worth $1,380,000. We will use data from the past 50 auctions to construct a simulation model that will be used to estimate the likelihood of winning this real estate auction. Landshark has data from 50 past auctions. Here we see 10 of these 50 auctions. For each auction, the bid amounts for each of the competitors has been listed and expressed as a percentage of the property value in the corresponding auction, as well as reporting the total number of bidders in each auction and listing the winning bid, which is the maximum of the competing bids. Using the data from the 50 past auctions, one can construct a histogram representing the frequency of the number of bidders in each auction. We see here that in 8 of the 50 auctions, there were 2 bidders. In 6 of the 50 auctions, there were 3 bidders, and so on. By comparing the heights of the bars, we see that the number of bidders was roughly equal for the values of between 2 and 8 bidders. This spreadsheet computes the outcome of an auction given values of the number of bidders and the bid values presented as percentages of the estimated value of the property. In the current spreadsheet, we see that there are 4 bidders and that we have bid values ranging for all possible number of bidders. In this case, there are ranges between 1 and 8 bidders. To actually compute the bid amount, the spreadsheet formula compares the bid index of the bidder to the number of bidders using an if formula. If the bid index is greater than the number of bidders, this formula sets the bid amount to be 0, effectively eliminating that bidder. Otherwise, it computes the bid amount as the percentage bid times the estimated value. As we see in the current spreadsheet, the first 4 bidders present a bid amount in terms of dollars, but bidders 5 through 8 effectively do not exist because there's only 4 bidders. So therefore, they have a value of $0. In cell B18, we have Landshark's bid amount entered. In cell B19, the largest competitor bid is computed by taking the maximum of the bid amounts. In cell B20, we use an if command to determine whether Landshark has won the auction or not by comparing Landshark's bid amount to the largest competitor bid. In this particular case, Landshark does not win the auction because its bid amount of $1,230,000 is less than the largest competitor bid of $1,250,100. So therefore, its value for winning is 0. Its return then is computed by taking whether or not it won the auction and multiplying that between the difference of the estimated value and the bid amount. To represent the fact that the number of bidders is not fixed at 4, but is rather an uncertain value ranging between 2 and 8, we will replace this entered value of 4 with an Excel formula. In this particular case, we will assume that the values of 2 through 8 bidders are equally likely. To do so, we can use the function rand between. And in this particular case, we just need to enter the lowest possible value, integer value, and the largest possible integer value. We will assume that between 2 and 8 bidders are equally likely. When we hit enter, if we tap the F9 key, we will see that a value between 2 through 8 is generated. Currently, the values for the bid amounts are fixed in the spreadsheet. For instance, the first bidder here is bidding 0.887% of the estimated value. The second bidder is bidding 0.716 of the estimated value. However, we know that the bid amounts for the competitors' bids are uncertain values. We would like to generate random values for these bid amounts in the same frequency which they occurred in the past auctions. One way to do so is to directly sample the data from past auctions. In the bid list worksheet, we have listed the bid amounts as a percentage of the estimated value for all of the past auctions in the data. To randomly sample from this data, we use a VLOOKUP function. And in this particular case, the lookup value is going to be randomly generated. To determine what the range of that random values are generated, we will go to our bid list data and we'll see that there are 1 through 250 possible bids. So therefore, when we enter our VLOOKUP function, the first argument will be rand between. We will randomly generate a bid number between 1 and 250 from the table array of listed bids. And we will tap F4 to fix those references, so we can click and drag those in just a second. We will be returning this second column because that is where the bid amount resides, and what we would like is an exact match, so we were going to type in false. Clicking and dragging this formula down and tapping F9, we see that the bid amounts now vary. What this function is doing is generating a random bid index between 1 and 250 and pulling that corresponding bid value and putting it in the cell. Now that we have the simulated random values for the number of bidders, as well as for the bid values in place, as we can see by tapping the F9 key, we would now like to track data over a large set of simulation trials. To do so, we first set up a table that includes the number of simulation trials that we want. In the current table, we see that we have created a table of 1,000 simulation trials that we would like to collect data for. In the first row of this table, we would like to link the data we would like to track. We are interested in whether or not Landshark wins the auction, which is in cell B20. We're also interested in what Landshark's return was for that auction, which is in cell B21. Then we highlight the entire range of the table, and we will automatically populate this table using the data table functionality. On the data ribbon, we select what if analysis, data table, and what we would like to do here is for the column input cell, we have the values of the simulation trial. The first trial, second trial, and so forth. what we would like to do is take that trial number and insert it into any blank cell of our spreadsheet, for example, D1. What this will do is force Excel to recalculate the entire spreadsheet with new sampled values 1,000 separate times. Clicking OK, we observe the results. So we have populated a value of 1,000 simulated auctions. Given this data, now we can track statistics over these 1,000 observations. To compute the probability of winning, we can simply sum up the number of times that Landshark won. So we see that it won 224 times. If we want to express this as a probability, we then divide by the number of trials, which is 1,000, or we can count that range. And so we see that when Landshark bids 1,230,000 on this auction, we estimate that the probability of winning will be about 20.9%. We can also compute Landshark's average return by using the average command over the return data. So here we see that the average return is 35,775 for this set of 1,000. Notice if we tap F9, these estimates of the probability of winning and the average return vary. This is due to sampling error. If we would like to decrease the amount of fluctuation in these statistics, we need to increase the number of simulation trials that we compute the statistics over.